prior to diving into the declaration, it's essential to initially explain the idea of subatomic fuel petals. The enormous Hadron Collider, LHC, operated by CERN, is a 17M circle of superconducting magnets. Furthermore, it holds the title of the most unmistakable and powerful particle smasher on the planet. This machine represents the pinnacle of human achievement. In fact, it is so powerful that it can reproduce the states of the universe's first moments after its creation. However, could the very machine built to unravel the universe's secrets unlock something even more significant? Established in 1954, CERN is one of the most eminent research organizations globally, with 23 member countries and countless specialists. It's a hub for collaboration and development. While the LHC is CERN's flagship project, it is only one aspect of a vast network of fuel petals and tests. Imagine a pathway, not for motors or people, but for subatomic particles, trapped in a trial of endurance and space itself. The LHC accelerates protons to nearly the speed of light, driving them on a collision course that mirrors the energy present just after the Big Bang. These impacts generate temperatures far exceeding the Sun's core. A vast array of magnets directs the protons along their path, while advanced cooling systems maintain the magnets at temperatures colder than space. The beams inside the LHC are designed to collide at 4 different points along the collider's ring, meeting the particle detectors at 4 designated areas: Atlas, CMS, ALICE, and LHCb. Each serves a specific purpose in investigating different aspects of particle physics. Together, these massive detectors act as grand cameras, capturing images of these high-energy collisions. Scientists then analyze the resulting particles, searching for evidence of the elusive Higgs boson, often referred to as the God particle, and other anomalies that could provide insight into the fundamental building blocks of the universe. By exploring the microcosm, we gain new understandings of the cosmos. Yet, with each answer, new questions arise, and with every discovery, new challenges present themselves. The LHC isn't just a scientific instrument, it symbolizes humanity's relentless curiosity and progress. It reflects our unwavering quest to understand the forces that shape our universe. However, as we continue pushing the boundaries of knowledge, we must remain aware of the deeper existential questions that inevitably surface. The risks of exploring the unknown. What are the dangers of probing the unexplored? Could our quest for knowledge unintentionally unleash forces beyond our control? Within the revered corridors of CERN, where human understanding is constantly expanding, a discovery has emerged that sends chills even through the most experienced scientists. Brian Cox, a former CERN physicist and a leading voice in particle physics, recently made a statement that left the world both fascinated and uneasy. Cox declared that the purpose of the LHC is to recreate a miniature Big Bang. Yes, you heard it correctly, a small-scale version of the very event that gave birth to our universe. He went on to discuss the profound implications of this objective, highlighting the LHC's potential to unlock mysteries such as the Higgs boson and probe dark matter, a mysterious substance that comprises a significant portion of the universe. Imagine possessing the ability to recreate the very forces of creation itself, the capability to harness the essence of the universe. It's a fascinating possibility, but one fraught with risk. The miniature Big Bang isn't just a theoretical concept, it's a real phenomenon occurring inside the LHC. The extreme temperatures, pressures, and raw energy involved recreate the conditions that existed at the dawn of the universe. It's akin to standing at the beginning of recorded history, witnessing the birth of existence. However, such immense power carries with it great responsibility. And that raises the question, what if something goes wrong? A real-life incident. Anatoly Bugorsky's nightmare. In fact, something did go wrong back in 1978. Russian physicist Anatoly Bugorsky faced a catastrophe that would forever change his life. While working at the UB-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia, a malfunction caused his head to accidentally pass through the direct path of a proton beam. The beam, with unimaginable force, passed through his skull, entering the back of his head and exiting through his nose. The experience was harrowing. He saw a flash brighter than 1,000 suns but felt no immediate pain. The beam's path left destruction in its wake, burning tissue and bone. Yet, he remained conscious and even walked himself to the medical center for treatment. The outcome was both disturbing and bizarre. The beam caused localized tissue damage, including hearing loss in one ear and partial facial paralysis. However, Bugorsky's cognitive abilities remained intact, and he continued his scientific career. This incident serves as a stark reminder of the immense energy and potential risks posed by particle accelerators. The dangers of a machine like the LHC should not be underestimated. The possibility of catastrophic reactions or alterations to the very fabric of reality is not mere science fiction but a genuine concern raised by respected scientists. The fear of creating a black hole. One of the most unsettling and captivating issues linked to the LHC's experiments is the potential creation of a microscopic black hole. Black holes are regions of spacetime where gravity is so intense that not even light can escape. They are cosmic vacuum cleaners, devouring stars and shrouded in the mysteries of the universe. The idea that the LHC could create one, even on a minuscule scale, is both awe-inspiring and terrifying. Could such a black hole spiral out of control and ultimately consume the Earth from within? Scientists have assured the public that any black hole created would be unstable and would dissipate quickly. Still, this remote possibility has sparked debates, fears, and wonder about the power we wield. To understand how the LHC could produce a black hole, we must first consider the fundamental mechanics of particle accelerators. When protons collide at nearly the speed of light, the energy produced is so immense that it warps the very fabric of spacetime. Imagine a stretched-out trampoline with a heavy object dropped onto it. The fabric bends. If the object is massive enough, it can create a deep well that pulls anything nearby into it. This analogy illustrates what could happen inside the LHC. In the realm of quantum physics, where the laws of the universe can seem both strange and magical, there is a hypothesis that extra dimensions could exist within our reality. If these extra dimensions are real, the LHC's experiments could access them, creating a gravitational well that might form a microscopic black hole. The curious dance of particles has caught the attention of many, including the late Stephen Hawking. In his compositions, he cautioned about a situation where the Higgs boson could become perilous at very high energy levels, possibly leading to an event called vacuum decay. Such an event wouldn't just annihilate Earth but could potentially destroy the entire universe. The prominent English cosmologist and astrophysicist Sir Martin Rees also voiced concerns about CERN's experiments. In his book on the future prospects for mankind, he explored the potential risks associated with particle accelerators, including those at CERN. Rees' warnings were not just cautious thoughts, they carried an undertone of existential fear. He outlined a worst-case scenario in which a failed experiment could trigger a phase transition that would echo through spacetime, resulting in a catastrophe capable of consuming the entire universe. While he assigned a low probability to such catastrophic outcomes, he maintained that even a slight risk deserved serious consideration. Researchers at CERN have conducted simulations, analyzed theories, and taken precautions to ensure the safety of the Large Hadron Collider, LHC. In fact, physicist Brian Cox himself emphasized the importance of these safety measures. Acknowledging the inevitable concerns and questions surrounding the LHC's operations, he reassured the public that strict protocols are in place, with thorough reviews and procedures to ensure that the LHC's work is conducted with the utmost care. Cox also assured that the energy levels involved in the LHC's experiments are well within the range naturally occurring on Earth, and that the probability of creating a stable black hole is astronomically low. Even if one were created, scientists assert that it would dissipate rapidly, releasing a burst of energy, a phenomenon known as Hawking radiation. Some have taken this idea even further, speculating that the LHC's experiments could open a doorway to another universe or dimension. While mainstream scientists generally dismiss this idea, it continues to captivate the imagination of many, fueling both speculation and fear. Could we accidentally unleash forces or entities beyond our comprehension? The possibility of creating a gateway to hell has even been sensationalized in the media, amplifying uncertainty. The concept of extra dimensions isn't new to physics. String theory, a leading candidate for a unified theory of everything, proposes that there may be more than the usual 3 dimensions of space and 1 of time. These hidden dimensions might be compactified or imperceptible, but in theory, they could be accessed or detected under extreme conditions. Consider the LHC as a key that could unlock these long-forgotten doors. When protons collide at unprecedented energy levels, they could, in principle, generate ripples that test these hidden dimensions. If such dimensions exist, the LHC may indeed reveal them. However, it's crucial to approach this with caution. While the LHC is a powerful tool, there is no definitive evidence to suggest that it will open a portal to another universe, let alone to hell itself. The allure of the unknown, combined with the enigmatic nature of quantum physics, will continue to fascinate the public. However, it's essential to remain grounded in science. Should we be worried about the LHC's potential dangers? It's easy to be swayed by sensational headlines and fears of global catastrophe, but the reality is that CERN scientists are highly aware of the inherent risks. They have taken extensive precautions to ensure their experiments are safe, continuously monitoring and refining their work with meticulous precision. The potential rewards of the LHC's research, breakthroughs in our understanding of the universe, the discovery of new particles, and the study of dark matter, are truly remarkable. The LHC is not just a testament to human ingenuity but also a window into the very fabric of the cosmos. However, like any great scientific advancement, it comes with its risks, and we must approach it with a sense of wonder, respect, and caution. The LHC represents the frontiers of scientific inquiry, where theoretical physics meets experimental reality. Its potential to answer fundamental questions about the universe, such as the origins of mass and the nature of dark matter, is immense. However, despite rigorous safety measures and extensive simulations, the LHC continues to inspire both curiosity and fear. The scale of the machine and the energy it generates are unprecedented. Each new experiment brings us closer to uncharted scientific territory. While most scientists remain confident in the LHC's safety, there are fundamental uncertainties. What if unforeseen anomalies arise that challenge our current understanding of physics and the laws of the universe? The LHC pushes the boundaries of human knowledge and tests the limits of our control over nature, raising existential questions about the potential consequences of altering the fabric of reality. As the LHC continues its groundbreaking work, scientists remain vigilant, constantly refining their methods to minimize any risks. The promise of discovery, the very nature of reality itself, drives them forward. Yet, despite the countless safeguards in place, we cannot ignore the fundamental uncertainties. The laws of physics, as we know them, could be forever altered by the discoveries made in the LHC's experiments. Could we unlock something so powerful that we might struggle to control it? These questions are not just the domain of theoretical physicists but concerns that weigh on the minds of many. In some ways, the LHC symbolizes humanity's thirst for knowledge, our relentless desire to unlock the deepest secrets of the universe. But this insatiable quest is not without its consequences. There is always the possibility that, in our pursuit of understanding, we might stumble upon something beyond our grasp, something that could be dangerous or uncontrollable. It is this delicate balance between exploration and caution that makes the LHC both a fascinating and unsettling prospect. While it's easy to get caught up in sensationalized fears about what could go wrong, it's crucial to recognize the immense benefits that such research could bring. The potential discoveries could reshape our understanding of everything, from quantum mechanics to cosmology. The LHC has already paved the way for uncovering dark matter, a phenomenon that could provide insight into the invisible aspects of the universe. This, in turn, could lead to technological advancements or breakthroughs we cannot yet imagine. However, the larger question remains: are we ready for the answers that lie ahead? The LHC stands at the edge of our knowledge, probing deeper into the universe than any instrument before it. With each experiment, the risks and rewards become more pronounced. Yet, in the end, the pursuit of knowledge, understanding the very building blocks of reality, may be worth the uncertainties we are taking a chance on. For now, CERN scientists and the global scientific community will continue to watch and wait as the LHC's experiments unfold. Their work stands as a testament to human curiosity, ingenuity, and, perhaps most importantly, the ability to dream beyond the possible. However, as we move forward into this uncharted territory, it remains essential that we tread carefully, with respect for the power of the universe and a commitment to understanding the forces we seek to control. In conclusion, while the LHC and its experiments continue to spark both awe and fear, it is clear that much is at stake. The promise of extraordinary discoveries is matched by the recognition that we are dealing with forces that could have profound, unforeseen consequences. This duality, the excitement of discovery combined with the possibility of catastrophic risk, is what makes the LHC a symbol of both triumph and the caution that must accompany our journey into the unknown.